If you're trying to become a profitable business, especially in the early stages of your business, feedback is much more direct. So you don't really have too much of a chance to BS yourself for a long period of time because otherwise you would go out of
Yeah.
business. It's a bit more unforgiving, whereas in the academic world, you're gonna get paid. People like Einstein, like pretty much anything and everything is attributed to Einstein these days, right? He would be the
Yeah.
one that
Yeah.
came up with space time and whatever and whatnot. And don't get me wrong, the guy was by all measures a genius, right? But the first guy to actually talk about space time, if I'm not completely mistaken, was Minkowski.
Yeah.
The Research Labs podcast by SundayPyjamas.
I'm
Yeah.
super excited. I think the first time we had a conversation, we went very deep about your PhD thesis, which definitely we can discuss some of it about. And apart from that, I think we have a lot more to discuss about the work you're doing in Web3 and the company you are building. So,
Mhm.
very excited to have this discussion with you.
Yeah, super excited too. So, really looking forward to it. So, let's dive right in, man.
I think it will be really nice if you could give us like a brief as to how you were in college and what are the subjects you were interested in, because that's
Mhm.
the time, a lot of things that you are doing right now started.
Yeah, I could actually give you a brief overview over my past and my professional, educational way. Let's start out with the fact that I've been super bad in both math and physics when I
Yeah.
was a student in school. So, never really was much into it. And physics for me was always this okay, there is some electric current or resistance that I have to compute, that kind of stuff, like super boring. Didn't really catch me
Yeah.
at all. And then I would graduate to high school and I would start high school. And that's when I got a new teacher who
Yeah.
really turned me upside down. So his
Yeah.
lessons would be so good and well structured and well prepared. And he would explain things in a way that made them click for me immediately. And I would essentially, by accident, become a good student. So I would write my first
Yeah.
exam with him, and it was really like the grade was really, really good. So I made like awesome results. And I was like, Jesus, like, what's going on here? I didn't even
Yeah.
practice really. I mean, I paid attention to the classes because they've been so good, but that was about it. And then I kept getting these good results, and I was like, "Huh, math is actually kind of fun, right?" And
Yeah.
physics, kind of the same story because I actually got the same guy in physics too. So that's
Yeah.
when I really started to get into it. And after a year or so, I was hooked. So then it became
Yeah.
really clear that I wanted to do something like in the engineering direction. And the
Yeah.
deeper I dug into physics, especially when it came to quantum mechanics, like the very basics that you do in school, in high school quantum mechanics, nuclear physics, and stuff like that, really kicked off an obsession. And by the end of high school, it became pretty clear to me that I wanted to be a researcher. I want to be like do some cool stuff like general relativity and all that awesome stuff that you can binge YouTube documentaries over and over on.
Yeah.
So I started to study physics. And then
I
at the
see.
beginning of my studies, it became clear pretty quickly that I wanted to do theory. So I wanted to dig into theoretical physics. And then it became pretty clear that to become a good theoretical physicist, you want to be good
Hmm.
at math, right?
Yeah.
And actually, math started to become so much fun that I picked up math as a second major as well, and actually did my ended up doing my master's degrees in both math and physics. And I'm just fast forwarding here a little bit. So in the meanwhile, I did some string
Yeah.
theory. So my bachelor thesis was actually on string theory, and
Yeah.
then this way I ended up in particle physics. And
Yeah.
when I was done with both master's degrees, I would then find a position right at the intersection of particle physics and algebraic geometry, essentially. And that's really been a super cool sweet spot for me because I actually like to communicate. I like to explain things to people. And
Yeah.
I would find myself in a position where the physicists, they would know about all the problems in nature. I'm
Yeah.
of course generalizing here, right? But they would know
Yeah.
all the problems, but they don't have any real. I mean, they do have solutions, of course, but they are looking for more solutions, right? And
Yeah.
the
Like better
mathematicians,
ways
they
of
would
doing
actually
things.
have all the tools, they would have all these
Yeah.
tools developed sometimes like 200, 300 years ago already. And they would like the physicists wouldn't know about the existence of these tools. So
Yeah.
that was kind of like a great position to be in because I would pick the interesting problems from physics and I would
Yeah.
pick the powerful tools from mathematics and then
Yeah.
kind of marry them or whatever you want to call it, like apply these tools, like all the essentially standing on the shoulders of giants, as Newton said, like just
Yeah.
taking all the great work from the mathematicians and actually telling people in physics about them, applying them to a physicist's problem, and also communicating them in a way and breaking them down in a way that a physicist could actually understand. So that was like my academic career essentially. So I would finish my PhD. That took me like pretty exactly 3 years. And after that, I would become a machine learning engineer because I didn't really want to. I mean, I did like physics and math, and I still do, but I didn't want to
Yeah.
go the postdoctoral, travel around the world kind of guy. I mean, not that I don't
Yeah.
like traveling. I do like it very much,
Yeah.
but I wasn't really willing to leave behind my family and all my friends. And I mean, it sounds kind of cheesy, but it's actually true. Wasn't really willing to make that sacrifice, especially in a globally connected world that we are living in today. I didn't really see. Yeah. Anyway, it was not for me. It just wasn't for me. So I was like, okay, what else can I do that's kind of cool and intellectually challenging? And AI is, since a bunch of years, it's like a pretty sexy topic for a lot of people, right? And I was like,
Yeah.
okay, computer programming, software engineering are things that are both intellectually challenging, but
Yeah.
also present a great opportunity to develop a good career, right? And
Yeah.
also the opportunity to eventually work for yourself, because that seed was also planted during the PhD, where I was like, okay, I know that later down the line, I do want to become a founder, essentially. So
Yeah.
then I worked as a machine learning engineer, as I said, and did that for 2 years. So we were actually optimizing water systems, like wastewater treatment plants, well fields, or making drinking water demand predictions and that type of stuff. And at the time when I would start my machine learning engineering career, I was also becoming interested in Web3 and blockchain, and
Yeah.
I would do that as kind of a side hustle. That essentially, well, when I realized that a lot of crypto is actually super dependent, the foundations of the protocols in particular are super dependent on very deep, complicated mathematics. Especially if you go like something like Polygon just recently launched their ZK EVM, I believe, right? Like all these zero knowledge kind of proof things, very deep mathematics that go into that kind of stuff. So I was like, hey, I can actually read those papers. That's kind of fun, right? So I
Yeah.
can pick up paper
Yeah.
and I can actually kind of understand what's going on there because of my math background. And then I was like, hey, in that sense, I do have a competitive advantage among most other people,
Yeah.
right? so
Yeah.
so I was like, that was kind of fun, and I would do it on the side and learn how to develop Web3 and blockchain based applications. And because I liked teaching throughout, a good chunk of my life, I would take on some students and like other software developers and would teach them how to develop applications. So that was kind of my first freelance work, so to speak, like taking
Yeah.
other program and showing them how to develop full stack blockchain based applications. And with that, the idea grew to found an academy for blockchain developers and yeah, essentially turn that into a business. And that's what I'm mostly doing today. But I also co-created this other project recently with one of close friends, Marvin Split, and that project's called DevPal. And this is essentially a developer studio where we help fill their developer needs and work closely with startups and actually develop solutions in all sorts of ways for them. That can range, like currently, that's ranging from something like digital identity, but also to infrastructure providers for blockchain ecosystems, like node
Mhm.
providers, managed node providers, and stuff like that, to games, like the gaming industry, like trading cards and stuff like that, that are Web3 based. And yeah, that's what I'm kind of doing. So I hope this gives you kind of a rough idea of what I've been
Yeah,
going through.
yeah. Not just ideas, right? I actually have few questions, lot of questions. You mentioned that when you were in your academic career, you were looking at things from a mathematics perspective and a physics perspective. And like a lot of physicists don't have the tools that mathematicians have already figured out. So when you mentioned it you spent around 3 years in that fields. So, I was curious to understand when you are doing those two things, how does your day look like or a month look like? In the sense, do you have to constantly update yourself with the physicist of what is going on in the problems you're trying to solve in the physics world? At the same time, you're also trying to learn more about math. Like how was that time like for you?
Yeah, great question. So from a topic perspective, I would say I would pick a physics problem that and try to understand it. And from that point onward, I would mostly do math. I would mostly learn about math because the problem, like to state the problem, actually wasn't that complicated. And I could ask other people and talk to other people in the early stages to figure out what are interesting problems for physicists. Because I didn't want
Got
to
it.
spend my time doing in a super crazy niche where I would
Yeah.
compute a thing and it would be used by like two people on the planet and that would have been
Yeah.
that, right? So I
Yeah.
didn't
Yeah.
want to like that didn't really excite me. I mean, there's a place for this kind of work, and I'm not saying this isn't important work. It's
Yeah.
just what wasn't too interesting for me. So what I would do is I would figure out, like, let's say the first year of my PhD was actually spent trying to figure out what's an interesting problem to solve. Okay. And that took quite some time. So I would first do something like differential equations for Feynman integrals, like that you could use to then essentially construct a differential equation. And then you could apply the theory of differential equations to actually solve the Feynman integral that you are looking for in the first place. But
Yeah.
that seemed kind of like super computationally heavy and ugly and not really fun. So
Yeah.
I was like, let's forget about that. And then we
Yeah.
had this idea of working with so-called Hopf algebras and applying
Mhm.
those to compute Feynman integrals. But again, this was more interesting actually.
Mhm.
But there were quite some competitors, and I was like the only one doing it in my apartment. So there was nobody to collaborate with whatsoever. And there was a
Yeah.
very strong group of people, of other researchers
Mhm.
that already produced some, like a lot of results in that field. And I felt like, okay, I'm probably not going to be able to catch up with them. Like even if I try to define a problem that I want to solve and then try to solve it, if it's interesting, those guys will probably solve it first because I'm just too slow.
Got
And
it.
then I, discarded that again. And then I would go to a conference actually pretty close to my hometown in Bonn, which is a German city. And it was a math conference, actually. But I would talk to another mathematical physicist, and he would tell me that, look, there are like people are computing these Feynman integrals in physics, right? And they want to do that. And one problem that they often encounter is that there are square roots in these integral
Mhm.
expressions. And this is a
Yeah.
problem because square roots are not necessarily easy to deal with a computer. Like if you want
Yeah.
to do computer algebra, it's not really easy to do that if you have square roots flying around, essentially. And I was like, huh,
Yeah.
that's a very general problem kind of thing.
Yeah.
It's not specific to the physical problem, so it pops up in all sorts of computations in physics. And
Yeah.
on the flip side, it's super simple to grasp. Okay, so essentially,
Mhm.
what we were looking for was you have a given square root in an integral, some square root,
Mhm.
and you would look for a variable change, like a substitution, like
Mhm.
substitute x for y kind of thing,
Mhm.
um, so that under your square root in these new variables, you would get a square so that the square root disappears. So that you would have like
Yeah.
I'm giving like the most basic example here because we're on a podcast and it's kind of hard to envision all that stuff. So, uh,
Yeah.
if you have like square root of y, okay, just square root
Yeah.
of y, the substitution that would solve the problem would be okay, replace y by x squared, because in these
Yeah.
new variables, you would have
Yeah.
square root of x squared, so therefore it's just x. Of course, this is not 100% true, but it's sort of true.
Yeah.
Okay. And if you go to something more sophisticated, and you don't have to
Mhm.
be super sophisticated, you can actually go like with something like square root of 1 minus x squared or something like that,
Mhm.
and then try to
Mhm.
substitute x so that the expression under the square root becomes a square itself, is already
Yeah.
a pretty deep problem. And in physics, you wouldn't encounter stuff like one variable and only one type of square root or something. You would encounter like gigantic expressions, okay, in
Yeah.
like
Yeah.
loads and loads of variables. And I was like, huh, that is interesting. So the problem I described, like with the 1 minus x squared kind of thing, that is actually related. That's one of the oldest mathematical problems, period. Like there are actually
Let's say.
maybe you've heard about the Pythagorean theorem, right? Like where you have
Mhm.
a squared plus b squared is c squared, and there are actually clay plates where
Mhm.
I think the Babylonians would solve that
Mhm.
problem. Obviously, not with modern notation and stuff like that, but they would essentially solve that problem. Um, you know,
Mhm.
I don't know how many thousands years ago.
Yeah.
So
Yeah.
it's like
Yeah.
literally one of the oldest mathematical problems. And I was like, that is pretty cool. Okay, so let's dig into that and let's try to understand that. And now let's try
Yeah.
to, once I understood the most basic example, let's see whether I can apply some of the knowledge of modern mathematics to actually extend that.
Yeah.
And that's actually what happened. So it was very basic, low on notation, which is good for communicating
Mhm.
it to physics because you don't have a lot of
Mhm.
mathematical machinery to explain. So every
Yeah.
physicist would know what a polynomial is, for example. Every physicist knows what a square root is. Okay, so
Yeah.
you can easily communicate that to physicists, and that was actually turned out to be a powerful thing, and that's what I spent my time on doing. So I would just like identify this problem, and then I would just keep pulling the thread, dig deeper, and eventually physicists would approach me and give me new problems and ask me like, "Hey, is this solvable with
Can I
your
do this?
algorithm
Yeah.
thing?" So I wouldn't even need to go ask. They would just come to me, and I would try to assess whether we'd be able to provide a solution. And yeah, eventually that turned into a couple of papers. So I wrote 4 papers on the topic during my PhD, and this has been great fun.
Yeah. The one thing that always, I would say, amused me a lot is that there are so many papers that are getting published every day.
Mhm.
So that's why I asked you, right? How did you, like, what were you doing at the time? And I think you mentioned that you spent the first year just to identify what is like a good problem to solve. But I think that itself is still a very big mystery to me. Because even, for example, what we do, right, when we're trying to find a problem to build a
Mhm.
product that can eventually convert itself into a startup company,
Mhm.
identifying the problem is the most important problem, if you know what I'm saying.
Yeah, it's certainly very crucial.
Right, exactly, exactly.
What you work
So,
on is probably the most that is the most important metric of all. Like, what you work
yeah,
on, definitely. You can spend especially in creative domains, you know? If you
yeah,
look at
yeah,
something like software engineering, entrepreneurship, or even art, you know, you can do a
yeah,
whole lot of things easily. You could spend your lifetime doing things that don't really interest anybody, you know?
yeah,
And on the flip
exactly,
side, you would
exactly.
like to give you an example from physics, uh,
Yeah,
regarding, you know, picking the right thing and doing just
uh-huh.
I'm not saying a little now it comes across like a little work. That is, of course, wrong. But have you seen the Higgs paper? I mean, you know Peter Higgs, right? The guy with the Higgs who introduced the Higgs boson. I think the original Higgs paper is like 2 pages. 2 pages, and
Got it.
it earned them
Yeah,
earned him the Nobel Prize, right?
yeah.
So it's very important that you pick the right thing to work on, definitely. I mean, there are, of course, other things you need to do, like, you know,
Hmm.
be very good at executing your idea,
Hmm.
right?
Hmm.
So you have obviously can have the greatest idea in the world. If you're not able to execute on it, that's worth nothing, right?
It's nothing. Yeah,
But
yeah, yeah.
yeah, but it is the most important foundation. I totally agree with that. Yeah. So
Do you think you can share, let's say, some strategies from the physics and the math world that can help identifying what is worth spending your time doing?
so essentially, what you don't want to be doing is working in a vacuum. I think that applies to pretty much any domain. Like what you want to be doing is, first of all, figure out what other people are interested in. What are problems where you can actually like, first of all, what are interesting problems, right? And this takes kind of a lot of time because this actually takes some experience. Like
Yeah,
because if you're entering a brand new domain, you won't know what's interesting and not. But you can make a conscious effort to get there, right? You can talk to a lot of people and then try to observe
yeah,
patterns. And this is what
yeah,
you should be doing. And on the other hand, you also want to find like problem market researcher fit, if you want to call it like that. So you want to find a problem that has a market,
yeah,
like that a lot of people encounter, and that you can
yeah.
solve, that you are particularly suited to solve, because that's actually
So,
not an
yeah,
easy thing to do either, because there are so many deep problems, especially in higher math and physics, that although you have a PhD in physics, you might be able to do one or two things here and there. But as soon as
yeah,
you move a little bit away from that, you have no idea what you're doing. Right?
yeah,
So, because all the other branches of physics are just so deep and took so long to build up. And yeah, I think you want to you want to be pragmatic about it. Don't just do something because it's I mean, people do that, especially mathematicians. They would just do something because it's interesting, like with
yeah,
no they wouldn't question whether it's actually useful. And I would say that even if you are a mathematician, first of all, I think that's, for most people, that's actually bad advice, because always want to make sure your work has a market. Okay, otherwise you won't be
yeah,
able to pay the bills, essentially. So I mean, there
yeah,
is this notion of doing what you love, and I certainly agree with that. I mean, you want to be doing what you love, but you also want to make sure
yeah,
that this thing that you love has a market, because
yeah,
otherwise, like, you probably won't have as much fun doing it if you are not able to even put food on the table, right? So and also, frankly, it's not that, humans have a single passion for something. That is just, in
Yeah.
my experience, not true. Like, for example, I have a lot of things that I do enjoy doing. I actually enjoy playing the drums, for example. That doesn't mean I'm going to go the route of being a professional drummer, for all sorts of
Yeah.
reasons, but the market isn't particularly good. Let's be honest. Like, I mean, there are people that earn a lot of money with that, but it's not, it's very
Yeah.
competitive and kind of hard to succeed. Like, lots of external factors and stuff like that. Whereas, for example, with math, when I realized I'm
Yeah.
actually pretty good at math, I can look at the job
Yeah.
market for mathematicians and I can see, like, pretty much everybody is in one way or another looking for these kind of people. Like, be it
Yeah.
as really a mathematician to compute stuff for banks, insurance companies, or even research. That's kind of like, yeah, that was like one consideration for me. Of course, now I drifted a bit here. So, coming back to the what's an interesting problem, it should have a market.
Yeah.
That's what I'm saying. Okay, it should have a market. And even in mathematics, even if you're doing very abstract math, you can
Yeah.
differentiate between something that someone computes and then nobody will actually use it again. A lot, like, for example, studying a very specific equation, that type of thing. I'm not sure whether it's, you probably won't know that it's actually interesting because you already died when people actually figure out
Yeah.
that it's interesting. You know what I mean? Like,
Yeah. Yeah.
so you want to pick something that is interesting to your fellow peers and try
Mhm.
to help them solve their problems. I think that's, like, just talk to people, essentially, bottom line.
Do, do you think you understand this after you, let's say, are trying to build a company? Because it sounds very like a business strategy. Or do you think
Mhm.
you understood this even when you were in the academic world?
I think I understood this when I was in the academic world as well, because and the reason is probably because we have actually names for some specific types of research that made it stood out to me that this is actually not what I want to be doing. So here's one example. So one branch of,
Yeah.
like, one very important branch of physics is called phenomenology. So you would have a particle collider, you would have certain processes you want to study, certain reactions, and you would have pheno people who actually compute the actual predictions for a given process. Okay,
Hmm.
like your
Yeah.
theoretical predictions for that. So this is very process specific, right? So this is
Got it.
literally
Yeah.
something that you would compute once, and once you know it,
Yeah.
you kind of, okay, I got that one done, like, off the list, right?
Yeah.
But I was, like, more into procedures, like general algorithms, like general tools that could be used over and over again
Yeah.
versus computing a very specific problem in nature, like a very specific thing, right? Where you compute it once and then you
Yeah.
kind of know it. And
Yeah.
that is, of course, a matter of taste. And there are armies of physicists just doing just that. And it's, like, a really crucial, important part of physics. Like, this people's work is really, really important. And I'm not saying, I'm also not trying to say that this work is kind of dull or anything. This work is super
Yeah.
interesting. It's just like, it's just bound to a very specific reaction most of the time. So people would do something like,
Yeah.
I actually also have a paper that's specific to a problem, to one of those problems, like
Yeah.
Drell-Yan scattering, for example, which is kind of a very
Hmm.
specific process. And yeah, I was just, I don't know. I always just felt, okay, for one, it's not really
Yeah.
as interesting for me as actual tools. And I'd rather study
Mhm.
methodologies and how to improve them. And
Yeah.
on the other hand, there's also this business thought of what
Hmm.
has a better market. Like, you could
Yeah.
say what scales better. Like,
Yeah.
what paper scales better, right? Is it
Yeah.
is it the
Yeah.
one
Yeah.
that's just computing one thing, and
Yeah.
maybe they figure out some cool technique along the like along the way, and maybe that's useful. But that typically would be a chapter in the paper where they do certain stuff, and this becomes useful later on. So it's not on
Yeah.
purpose necessarily, right? It's still like the initial thought is still, hey, solve that problem in whatever way, right? There was also this thought of how can I make my work last and actually, yeah, knock off more problems in the future. How can I make this useful even for people 20 years from now?
Yeah.
And
Yeah.
uh, the other thing, I picked this up from Naval Ravikant, which you might know. He's pretty popular on
Yeah.
Twitter, right? And so
Yeah.
he would say something. There's his "How to Get Rich" podcast episode, like, right?
Oh
And
yeah.
I listened
Yeah.
to
Yeah.
that quite a bit.
Yeah.
I'm not going to tell you exactly how many times because that would be totally embarrassing. But I listened to it a lot. Okay, and there's this one passage where he would say, "You want to become the type of person that so that
Yeah.
other people want to do deals through you," and that
Yeah.
stuck with me. And I would actually listen to that episode while I was doing my PhD, and I was like, "Huh, let's apply this to my current working context, and let's try to
Yeah.
become the guy that other people would like to do deals with." And of course, you want to
Yeah.
apply that to the academic world and stuff like that. So what are deals? Well, deals are collaborations for papers, right? So how can I
Yeah.
become the guy that essentially needs to be that you want to have on your team as a, even if
Yeah.
it's just as a communicator, right, between the different camps
Yeah.
of physics and mathematics. And
Yeah.
yeah, that's actually great advice in general, whether you do it in business or academic world. Yeah. So I actually forgot the initial question, but whatever. Yeah. So hope that answers it.
Yeah. We were discussing, is this strategy that you learned after you started your business, or you actually knew it even when you were in college? That was the question.
Yeah, I actually, yeah, I actually did it back then, exactly. But let me tell you, business definitely reinforces this. Business definitely
Got
reinforces
it.
this, especially because
So
you have less of a safety net. If you trying to become a profitable business, especially in the early stages of your business, feedback is much more direct. So you don't really have too much of a chance to BS yourself for a long period of time because otherwise you would go out of
yeah.
business, So it's a bit more unforgiving. Whereas in the academic world, I mean, you're gonna get paid whatever you
Yeah.
do, right? At least a certain base salary, right? So
So I do have questions about, the innovation models. For example, even all the people who are researching in an academic world are trying to come up with new things which are useful. And even in the startup world, right, people are trying to do things which are useful. They're also trying to come up with new things. And
mhm.
in my mind, I see both of them as trying to achieve the same results, just a different way of going about it.
Yeah,
Does that make sense?
I would actually agree with that. Yeah, I would actually agree with that. So I would change that slightly to trying to improve upon what's already been built, because people
Got it.
have this idea about innovation that some
Yeah.
genius, especially in physics, some genius sits somewhere
Yeah.
and has this
Yeah.
brilliant idea. I mean, there is a wonderful book by, I believe the guy is called Matt Ridley, and the title is How Innovation Works. Definitely recommended reading for anyone listening. Beautiful book, and I totally agree with that. When you actually work in the academic world,
Yeah.
you realize that, for example, people like Einstein, like pretty much anything and everything is attributed to Einstein these days, right? He would be the
Yeah.
one that
Yeah.
came up with space time and whatever and whatnot. And don't get me wrong, the guy was by all measures a genius, right? But the first guy to actually talk about space time, if I'm not completely mistaken, was Minkowski.
Yeah.
And in the normal world, like non-physicist world, nobody knows Minkowski, right? But
Yeah.
he was actually
Yeah.
the
Yeah.
one introducing the idea of combining space and time into a merged thing. Um, and that is very often attributed to Einstein, I would say, and it's just not true. The guy talked about it ahead of Einstein for sure.
And I
So
think this
that
happens in
sense,
the physics world quite often, actually. A lot of inventions are not a one-man show. It's a team play. But when it comes to recognition in the culture, let's say, people remember
mm,
only the one guy or the two people who were involved, not the whole team.
yeah, exactly, yeah, totally. I mean, same with Bitcoin, right? Everybody says Satoshi
Yeah.
Nakamoto, right? And
Yeah.
if you look at the reference and all the hard work that came before it, you would go like,
Yeah.
even in the case of Einstein, you could go like, actually, it was just a matter of time until somebody would do it. You know,
Yeah.
like with
Yeah.
Bitcoin, for example, with all the
Yeah.
prior work, it's just a matter of
Yeah.
time until somebody would do that, and then the guy or gal is just in the right place at the right time and connects the dots. And don't get me wrong, this is like a monumental thing to do, especially in the case of Bitcoin, especially in the case of special relativity, for example. But I will say that for especially special relativity, so Einstein's first theory of relativity that was relatively simple compared to what he
Mhm.
came up with later. This was just a
Yeah.
matter of time, in my opinion. We had the measurements, we had all the contradictions from the experimental side
Mhm.
in physics, and it was
Yeah.
just like, okay, if you look at what's already been developed, I wouldn't have been surprised if somebody else would have solved that problem like a couple of years later, right?
Yeah.
So on the flip side, one can definitely argue general relativity is a whole nother beast.
Mhm.
And
Yeah.
Einstein came up with that too. And of course, he did a lot of other immensely useful stuff for humanity. So by all means, the guy is a genius. I'm just saying it's not that he would come up with all that stuff on his own. But again, as Newton said, he would stand on
Yeah.
the shoulders of giants and then
Yeah.
just build cool stuff on top of it.
Yeah.
But he
Yeah.
certainly didn't invent physics.
Would you like to discuss more about, let's say, the business you are doing right now and the company you guys are building?
Sure. Sure. Yeah, we can do that. Totally.
Okay. So you
So,
mentioned that you were doing machine learning, and then right
mhm.
around that time you got interested into blockchain, and then you started training some developers, and right now it seems that you're doing it full time and nothing else.
Yeah. I'm doing it full time.
Right.
Yeah, definitely.
So
Yeah.
could you share more about what different things you are doing in blockchain and Web3 at the moment?
Yeah, sure. So maybe then first the academy. So
Hmm.
after getting my first students and working with them, I would found the so-called Web3 Developer Academy. And
Hmm.
the way this works currently is that this is a premium coaching for
Hmm.
aspiring full stack Web3 developers that
Hmm.
are looking to work in Web3 full time, either as an employee, but most people, frankly, rather as a freelancer or even a business founder later down the line.
Hmm.
And typically, what I tell people is if you want to do this, if you want to go this route, you
Yeah.
need some sort of programming experience from before. It doesn't have to be web development, although web development is probably the best foundation for Web3 development. It could be data science, it could be machine learning. It could essentially it's just about your way of thinking and your capability to think critically and to solve problems. So there's a certain barrier to entry that of course you can build up in other programming domains first or by yourself, but I'm not going to get
Yeah.
you over that hump in a couple of months. So if you are not a
Yeah.
critical thinker yet, then
Yeah.
it's probably going to be difficult for you to succeed uh, in the academy. But I definitely do take on people who have no programming experience whatsoever, and then we just figure it out. So we just
Yeah.
do some sort of expectation setting because People often will tell you that blockchain pays a lot of money, right? So that is one prime motivator for people going into blockchain, because it just
Yeah.
pays well. And really, it does pay well. But
Yeah.
if you are not a programmer uh, right now, and you have no programming experience whatsoever, I am not going to turn you into a 150K per year developer in 4 months. That's just not going to happen.
Yeah.
And it's not going to happen with a 2-week tutorial on Solidity either, on YouTube or whatever.
Yeah.
Right? Not going to
Yeah.
happen. So people in blockchain are mostly paid a lot, I believe, because usually once someone figured out how to get into blockchain, they already are a pretty decent developer, because it actually takes some experience to put all these moving pieces together. So they are not so
Yeah.
much paid because of the fact that they're doing blockchain in particular, but rather because in order to get into blockchain, you have to learn a lot of different skills, and that's what they are paid for, right? And you have to have some
Yeah.
sort of experience already. And I think that's the reason why salaries are comparatively high compared to something like classic front end development or whatever. Although you can do very decent with front end development too, right? So nevertheless, it's there is of course this other component that smart contract development in particular is very high stakes. So you can't make any mistakes, right? So that's also, of course, a good thing for developers, because if you can write these things, you have a lot of responsibility, right? You can't fix any bugs later.
Yeah.
So you want to make sure
Yeah.
that this thing that you are building is really battle tested. It's audited by other companies as well. And it's a high stake process. And as always in the world, like the higher the stakes in any given deal, typically the
Yeah.
more, like the higher the payload, the higher the cut that people who are facilitating the deal can get out of it, right?
Yeah.
If you can
Yeah.
do 10 mistakes over and over again, I mean, why not let a beginner do this, and you can always fix it later, right? But in blockchain, you often only have one chance, so you better want to get it right. And that's also what contributes to the area of development being pretty well paid compared to other areas of software development, I believe. So what we're doing is people
Yeah.
would come in and they would get a personal onboarding with me, and I would introduce them to a community of other blockchain
Yeah.
developers. So we have a whole community around the academy. So all of the different developers who are, by the way, coming from all around the world. So we have people from Australia, the US, Germany, Afghanistan, Dubai.
Yeah.
So it's very widespread, which is great, of course, because you have lots of different cultures, which I really like about it. And
Yeah.
then people would have a community. They would get e-learning material. So we would have I recorded throughout the past year. I recorded a lot of material for them
Yeah.
to learn full stack development, from writing tests in
Yeah.
JavaScript to Solidity to React to Redux, and to connecting libraries like ethers, for example. But then also lessons on the blockchain protocols themselves, right? Like, what is a blockchain? How does consensus work? What is a mempool even? What's the purpose of consensus algorithms like proof of work or proof of stake, and all that type of stuff. So that will take them to work through this material. It'll roughly take them 6 months. And after that, or let's say during that, we have live mentoring sessions. So twice a week, they could get in touch with me live in a call, and we would just bounce off ideas and talk about various kinds of problems that they might encounter or questions that they might have. And we also have this beautiful thing called an accountability partner program. So what you would actually get when you enter the academy is a learning partner from somewhere around the world.
Mhm.
And so
Yeah.
it's essentially a gym buddy for blockchain development. Okay, so somebody
Yeah.
to hold you accountable, and that has been proven to be very effective. Because let's be
Yeah.
honest, like
Yeah.
the
Yeah.
biggest hurdle is not the technical knowledge itself, but rather
Yeah.
the fact that
Let's just
you
keep
have
at it.
very
Yeah.
yeah. Yeah,
Yeah.
you wanna keep going, okay? This is
Yeah.
where, most people have the most struggles with, is they at the beginning, they were all pumped up, right? I mean, blockchain development is so
Yeah.
great, the whole Web3 space is so great, and there's a ton of money to be earned and whatnot. And and then they, enter and start the process, and then they find themselves learning how to loop over arrays or code solidity mappings in some very niche contract or whatever.
Yeah.
And then what this does is it doesn't provide a lot of instant gratification at the very beginning,
Mhm.
which is
Mhm.
always something people are drawn to naturally, right?
Mhm.
So that's
Mhm.
just how the human species works. So you have to
Yeah. Yeah.
battle
Yeah.
that. And
Yeah.
on the other hand, it's also, and I had this realization recently, that it's actually kind of hard to find flow when you're just starting out. So the
Yeah.
beautiful thing about being a programmer is that you at some point develop this capability of switching on flow state immediately, which is very rewarding, right? Because you are super productive in that phase of work. And typically, programmers are, yeah, relatively well defended against stuff like continuous meetings and stuff like that. So that is one thing. So to get to this flow state, um, developers have actually have to be pretty experienced in my experience already, because you want to be at a skill level where you actually know how things roll,
Yeah.
and at
Yeah.
the beginning, and to a certain degree, always when you're learning new stuff, that's just not the case, right? You're just
Yeah.
struggling and stumbling all day long.
Yeah.
That is something that I think, if you're not used to that because you
Mhm.
weren't that much of a problem solver type of
Yeah.
guy or girl in the past, in your job,
Yeah.
because there are certainly jobs that are that way, right? A lot of, for example,
Yeah.
selling. I mean, not that selling isn't problem solving in some ways, right?
Yeah.
But you get what I mean. Like there, it's much more about like communicating and how to structure
Yeah.
your questions and stuff like that. And it's much more
Yeah.
about psychology, actually. And
Yeah.
if you're coming from math or physics or some sort of science, you are much more used to this
Yeah.
frustrating learning experience at times, you know. But many
Yeah. Yeah.
people actually aren't. So that's also one thing where the accountability partnership really helps, I believe. And of course, then they can reach out to me always via chat. So we have our own dedicated app for that and stuff like that. And then once they are through, I actually help them to develop their careers. So I would actually, no guarantees, because I mean, that's their life, right? And
Yeah.
it's upon, their responsibility to take care of that. But I can certainly
Yeah.
help in whatever way I can with my network, with advice on how to build up a social media following, how you would market yourself, about the importance about becoming a writer if possible, and stuff like that. So that's definitely something that is included as well. And yeah, just looking for a long-term relationship where I can produce these people a, in the ideal case, a relatively quick return on invest, not only knowledge-wise, but also uh, when it comes to financials, and actually make sure that they earn more money later down the line that they spent on getting the education in the first place. and ensuring that
Yeah.
this happens as quickly as possible, and then just staying in touch with them and supporting them if they want to, right? So that's how this kind of thing works currently. And what they are learning is, again, not only smart contract development, but full stack Web3 development, where they are at the end able to spin up their own MVPs for any business ideas that they might have, or yeah, frankly, work on MVPs for any startups they might want to work with, right? So that's that. And then we also created this developer studio called DevPal very recently, and we're currently onboarding our first clients for that. So this is an developer studio of expert software engineers. So currently it's just my partner and I
Yeah.
in the game. So he's very, very experienced in full stack development. Not as experienced in blockchain
Yeah.
development as I am, but we kind of have like a great buffet, or a great buffet, I guess is the English pronunciation for that. So great buffet of skills. Okay, so he's super talented and experienced in all questions regarding front end and full stack, and I can cover for the Web3 part of things. Although he's also very good in that regard already. So it's not that he is completely inexperienced in Web3. I'm just saying, like, that's kind of like how we divide our responsibilities at the moment. But yeah, that's been going great in the last couple of weeks as well, and that's what I'm doing.
I see. Have you guys like maybe considered partnering with startups who are looking for blockchain developers, in a way that you are training developers, startups
Mhm.
want to hire developers,
Yeah,
so why not partner with them? So like
yeah,
students who are graduating from your program can
yeah.
directly start working with the partnering startups. Is that
That
something that you have been thinking?
Yeah, that's definitely something that is already sort of going on, because my first, I mean,
Got it.
the academy is not that old. I mean, I founded it last year, and but this is something that is currently going on. Actually, yeah,
Yeah.
we were making some first moves into that direction. So, for example, there is a trading card game called Dark Mythos, which is based on the IOTA ecosystem. And they actually allowed me to share some of my work with my students already, so that they can, even during the learning process, already get their hands on some real world code and some real world project that eventually will make it to mainnet, And this is definitely something that I'm very interested in and currently developing already, because I don't want to be that type of guy that just sells like a fully automated course, and then whatever you do with
Yeah.
it, you do with it. And most people just, I mean, don't get me wrong, Udemy and all these platforms are great, but the success rate is relatively low. Like, if you look at
Yeah. Yeah.
who
Yeah.
starts a Udemy course and who actually
Yeah.
completes it, the fraction is pretty negligible. And I don't want
Yeah.
this
Yeah.
to be
Yeah.
the case for the academy, right? So the academy should really be a place where we aim for 100% success rate, where it's really,
Got it.
name of the game is to
Yeah.
make you learn that stuff. And even
Yeah.
if you
Yeah. Yeah.
yourself want to, like, not want to give up, but you are, you know, questioning yourself and your abilities, and we're there to help you and support you along the way, because it is a long journey. You're not going to learn blockchain
Yeah.
development in a matter of weeks. Not going to happen, right? So
Yeah.
yeah, but this thing with DevPal,
So
for example, this is also an opportunity for us to,
yeah.
you know take students from the academy and then maybe employ them, or take them as interns, or take them as freelancers, and work with them in that way
Yeah.
later down the line. I mean, currently it's just like my partner and I, but certainly if that thing scales, we'll need help, right? So this is
Yeah.
also an opportunity where this might fit together, but it's still very early stages. So yeah, anyway, that's kind of the roadmap for that one. Yeah, and it's already in the process. Uh,
That makes sense.
yeah. materializing.
How do you think? Yeah. So whenever, let's say, you have the academy in place, and this is certainly a new idea, the developer studio, but there are like a lot of different things that can be done. So how do you
Mhm.
think you and your co-founder goes about deciding, okay, let's do the developer studio now because that makes the most sense business wise? Is it something that you feel that can be achieved relatively easier than, let's say, something like
Mm,
how did that decision making go for you guys?
yeah, we're still figuring that out at the moment, actually. So I'm currently I would still consider the academy my top priority because that's the thing. I found it myself. I do have a bunch of clients there already and students, and I am not going to let them down in any way. So if I realize that other projects, work, whatever, would clash with the interests of the academy, I would prioritize that. But um, on the flip side, this other thing, DevPal is also,
Yeah,
great. And this has so far been a great partnership. But given that I have some dual focus there, I would
yeah,
actually, yeah. Well, let's see how that goes. We still need to figure that out. Okay. But my partner at DevPal, Marvin, he's a great guy, and I'm 100% sure that we'll figure this out very smoothly in a way that is very reasonable and pleasing for both of us, and all and frankly
yeah,
also all of our clients, right? So we have no
yeah,
just because I'm saying I would the academy is my most important thing right now doesn't mean that I would
yeah,
just screw over all the other things. It means that I would slowly work back or whatever, right? And make sure that yeah. It's just too early to answer that, actually. It's just too early. We're still
I
at
completely
the very
understand. Yeah,
very beginning and figuring that out. And yeah, but it's an exciting times so far. Exciting times, and we do have some great clients already. Uh,
yeah,
in the making or already under contract, and great projects. So I'm pretty pumped about this. On the one hand, to work on this myself, but also as an opportunity for the students of the academy to get in touch with these projects eventually, maybe work on them and support us there, and generally benefit also from the experience that I gained during these projects, right? Because yeah, if you are on the flip side, if I'd be like a full-time academy guy without
hmm,
any
yeah,
connection to the outside world, then that
yeah,
would be a problem too, right? Because I would essentially just selling shovels without knowing how to dig for gold myself,
yeah, yeah, yeah,
That,
yeah.
right? So I don't want to be that guy either,
So,
right?
I think this is a great segue to ask you this question about the Web3 space overall, because I would say the last few years have been quite really something. It was not so interesting, and then it became the most interesting, and then again, it's kind of went completely in the other direction, and now it's kind of somewhere in the middle.
Yeah,
So,
it's kind of recovering at the
how
moment. Yeah.
right? So how do you, let's say, make sense of that? Because all the, let's say, Web3 builders and engineers and founders that I have been talking to, so I talked to them, I would say last year, September, October, when things were going really down. And
Mhm.
the perspective they shared is that maybe the things like the NFT market and the trading sounds dicey, but the core problems that can be solved using the blockchain technology is still very strong. Like, for example, the company that I shared with you, Arda
Mhm.
Finance, even they are doing risk management. And
Mhm.
The perspective those guys shared with me is that all the big guys, they only have very few enterprise clients and they're building for them, and they see an opportunity in this market actually.
Yeah.
So I would like to ask your perspective as well as to how do you see it?
Yeah. Yeah. Great question. So actually, I often had to answer some variation of this. Like people are like whenever, especially when the market is down, people would always ask me that question, right? Like now that crypto's down, everything goes south, and what do you do? And I'm like, I really don't care. I really I couldn't care less. And I mean, I'm not even paying attention to the prices at all at most
Yeah,
times because if you really understand what crypto and Web3 and blockchain technology is about and what it enables, is that you actually see that this kind of stuff enables to solve problems that weren't solvable before. That just you just couldn't get it done with software before that innovation of blockchain. And I'm
yeah,
not saying that it has to be a blockchain. There are obviously other architectures of decentralized protocols that get the same thing done. Like, for example, IOTA's Tangle infrastructure to at least to a certain degree, and for specific applications. And there is more and more stuff to come in that direction. But blockchain has just been the first type of architecture, of software architecture, that enabled these kind of applications, and obviously Ethereum in particular. So as you
yeah,
probably know, Bitcoin isn't Turing complete, right? So you couldn't write a whole lot of programs on Bitcoin, or essentially almost none. And Ethereum really enabled this rich universe of trustless, immutable contracts written in code, or vending machines, or
yeah,
whatever you want to call it, right? Programs that are,
yeah,
yeah, that enable a whole lot of new real world applications that couldn't have been solved before. And once you see a couple of these examples in practice, and I mean, it does take some deep technical insight to really make that click in your head. But once
yeah,
you're past that
yeah,
point, you go like, there is no way crypto's gonna die. There's no way blockchain is just, a hype, or I mean, it certainly was or is maybe still a hype, but there is substance. There's real substance. There's real utility. It's not just air money. I mean,
yeah, yeah, yeah,
any money is kind of air money. You know what I mean? But but the fact that ether has value, and that you have to pay for it with your hard-earned dollars, right? That is not purely based on speculation. It is just not true. And
yeah,
anybody who tells you so, you'll probably wake up, 20 years from now and go like, ah, geez, it's still around, right?
yeah,
I don't see it go away anytime soon. So I couldn't care less about the newest dramas, and like the latest dramas and rug pulls and whatever. I mean, don't get me wrong in that regard. I'm super sorry for everybody who got cheated and scammed in this space, because it's full of scammers. It's full of scammers. It's full of projects that won't last. Like,
yeah,
pretty much, you could say pretty much, dot-com bubble type of thing. I'm not sure whether that comparison is completely accurate, but that's how
yeah,
I see it. I'm like, okay, yeah, 99% of crypto projects probably will go south. Okay, yeah, that's probably right. And
yeah,
yeah, a lot of people get scammed because it's brand new technology. And at the time when credit cards were introduced, for example, a lot of people would get scammed with, credit card procedures,
yeah,
whatever. So whenever you use a new techno or introduce a new technology, especially in the financial sector, you are
yeah,
guaranteed that people will get scammed. So as sorry as I feel about them, that is kind of part of the innovation process of it. It's super annoying, and I couldn't hate it more. But it's also naive to think that you could get this kind of innovation in the financial space without attracting the scammers. So
Yeah.
that's that's the thing. So, but this will go away as well as as more and more people understand how to build more and more secure and user-friendly applications. And I don't see it go away anytime soon, honestly. It's not as big as the internet, but it's pretty big. You know,
Yeah.
it's a pretty big revolution in my opinion. That's the point. Like if you have something that enables you to solve a greater set of problems that you were able to solve before, that's probably going to stick around for a while. That technology has a
Yeah.
fairly long shelf life, so to speak. Okay, so it's in my
That makes
opinion,
sense.
it's a very good idea to bet your career on this if you're still fairly young. I think that's a good
Got
field
it.
to get into. So yeah.
Yeah, that makes a lot of sense actually.
So one thing I could share is my approach to work in general, um, where which I think is relatively unusual. So just to give you a
Mhm.
quick overview of how I roll these days, it's
Mhm.
let me start by saying it's a constant struggle. It's a constant
Yeah.
struggle to protect your time. Okay, that is certainly true, and
Yeah.
I am also figuring it out as I go. But what I've been doing for this entire year now, since 1st of January,
Mhm.
essentially, was I would
Mhm.
work only 4 days a week. I would work only 6 hours a day. I would be
Mhm.
utterly ruthless about dodging meetings.
Yeah.
And I would actually only take on meetings Tuesdays and Thursdays. And Monday, Wednesday, Friday would be all by myself. Just me and my computer. And
Yeah.
under these conditions, I think there are actually a lot of studies that show that you actually can't work that much more than 4 hours of deep work. That's pretty much if you're really, really good, you can take like 4 hours of deep problem solving work, and then that's about it. So I was reading these studies, and obviously this is highly applicable to my current area of expertise or to my career in general. Like it applies to mathematics as well, right? So whenever you have something like
Yeah.
deep problem solving thinking involved in your work or a lot of creativity in general, so it also applies to
Mhm.
art and like essentially any creative
Mhm.
domain where you're not just laying bricks on top of each other, right? Although I would make an
Yeah.
argument that
Yeah.
these people should also work less. But anyway,
Yeah.
uh, then your maximum capacity as a human is pretty
Mhm.
much capped at 4 hours. And there are actually a lot of studies these days to back that up. So why
Mhm.
on earth would you work 80-hour weeks? I mean, it just doesn't make too much sense. And I actually think most of the time it's just status signaling. Like you patting yourself on the back for being such a, great worker and so dedicated and sacrificing blood, sweat, and tears and whatever. Right.
Yeah.
And I just found that this is not an effective way to work at all. It's still ingrained in society, but I think people would actually be much better off if they would just get 6 hours per day done, where they would split that up into uh, as much deep work as they can, and then some sort of admin stuff like email or actually meeting people is obviously super important to socialize
Yeah.
in all sorts of ways. But if you can carve out 4 good hours at some point during the day, particularly the morning when you're fresh, this will
Mhm.
be uh, an enormous game changer for your productivity. And I actually wrote my PhD thesis that way. I never mentioned that uh, during the recording before, but I would actually write my entire PhD thesis in a couple of months by only writing 4 hours a day. I would go
Wow.
into the library, I would shut everything off, I would, put my
Yeah.
smartphone away, actually have no internet connection for the most part, and I would just write 4 hours, and then I would be smashed. Like if you are really, if you really manage to build these kinds of environments where you can fully focus, where you're not distracted or tapped on the shoulder or whatever. You are just you
Yeah.
and your machine that you
Yeah.
use for working, and then you crank it out for 4 hours
Yeah.
straight, you'll be smashed. There's no way your brain will
Yeah. Yeah. Yeah.
be able to do any more work, right? But
Yeah.
you'll have half the day left. You'll have half the day to do things like that are not as mentally challenging, like, for example, physical exercise. You would be able to incorporate meditation into your day. You'd be able to actually go out while the sun is still up and get
Yeah.
some, vitamin D and stuff like that. So, and that again is actually a very, positive cycle. So, and I made
Yeah.
the experience that I'm just much, 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 much more productive that way. The only problem with that is, of course, no, most people can't implement that because their days are too sliced up with all sorts of meetings, and they probably don't have
Yeah. Yeah. Yeah.
too much control over that. But I think actually, as a business owner, that's a horrible idea especially if you're
Yeah.
working with creative people. All right. So
Yeah.
yeah, that's just we could have another episode where I go all nerdy about this because I actually deeply care about the topic. But let's keep it at that and probably call it a
So
day here.
there is also, I would like to add, there is also an essay by Paul Graham, who is the
Hmm.
founder of Y Combinator. And
Yeah, yeah,
if you have not read it yet, I encourage you to read it once. It's called Maker Schedule and Manage Your Schedule.
be a great one. Yeah, yeah. Let me
Yeah.
check that
So
out.
what you are meant, yeah. So what you are mentioning would be a maker schedule where if you are a developer, software developer, and you're trying to solve very big problems, it requires like, it's like, loading the problem in your RAM, and that takes like an hour. So the first hour, you're just loading all the information you need to solve this problem in your brain, just to like, get started. And you spend the next 3 to 4 hours just to focus and try to figure out, okay, what can I do about it?
Yeah,
Whereas if you're a manager, right, you can do 10-minute calls, 15-minute calls. You can do a
yeah,
sales meeting in 15 minutes, do a design meeting in the next 20 minutes, and you're completely fine because you don't have to solve any real problems in that manner. Yeah.
exactly. Yeah, I'll definitely check that out. Let me before jumping off. Let me just recommend
Yeah.
one book to you by the
Definitely.
30-second Signals or Basecamp founders, Jason Fried and David Heinemeier Hansen. So if you read no book in your entire life, but only one related
Yeah.
to getting work done and how to work, you should read
Mhm.
It Doesn't Have to Be Crazy at Work. Just read that single book and thank me later. So yeah, that's about
Yeah,
it,
I'm
man.
just writing it down. That's about it, man. So, before you go, I would also like to ask you how was it like to be on the other side? I know I ask questions at times which might not be that comfortable, but how was your experience today?
Yeah, I've had a great time, man. I really had a great time. This is actually something that I deeply enjoy. I'll probably start my own and have you there.
I highly recommend it actually. I highly
Yeah,
recommend you starting a podcast also because I really feel like a lot of podcasts don't really provide any value. They're just for entertainment.
yeah,
And if
yeah, yeah.
if people like you who are actually doing difficult things, if you guys are the one who actually do a podcast, I think that will bring a lot of value actually.
Yeah, I let you know, man. I let you know. It's just something
Yeah.
that I really enjoy. I got to say, meeting interesting people and yeah, getting to know other folks that you can learn from. I think is a great way of.
Yeah.
It's just a great routine for life, It's been a great pleasure, man. Thanks for having me. And shout out to
Yeah.
Anton Hüstege, who got the two
Uh-huh.
of us in touch. Big shout out to him.
Exactly.
Good friend of mine,
Yeah.
and very grateful that he took the time to introduce me to you, and super grateful to have been on that podcast, man. It's been great fun.